coming up, so
Well,
I wanted to go over these.
you direct me. Where you want to start? Hold on.
Um,
Hold on. Somehow this keeps happening, and I haven't figured out why. Let's see if I open it up like this, if it isn't a little easier. Yeah, it actually is. Okay. Where?
I just kind of wanted to redo the problems because I got these wrong on this test, on the pretest.
So we should start from the top.
Sure.
All right. Get to the top. I assume that number 3 is the highest one.
Mm-hmm.
What does LT colon I can solve by factoring mean?
Oh, that's just the learning target I can solve by factoring. We took this at like the beginning of this year.
Okay. Okay, and this
At the beginning of this
red,
grade. So
red is your teachers, and
the red was me at the beginning of the year, and I'm just trying to go back through and redo them because we have our final for this on Monday.
Okay. Okay, I like this. I like this. I like this. Should give you an answer of 0, 2, and minus 2.
Mm-hmm.
Is that correct?
I think so.
Okay. I can't tell. I'm used to when the teacher makes notes in red, I'm used to something being wrong. So, no, that is correct. Okay. So, let's look at number 4. So this one, you factor out a greatest common factor. Which is 5x squared. Behind x times 4x minus 3 squared. You need an x right there. Okay.
Right there in front of the.
Well, let's go back and look at this from the beginning. Okay. Here's what I'm going to factor out from there and there.
Okay.
Now I see the other thing you can factor out. You can also factor out a 4x minus 3 to the 4th.
Yeah.
Wait. It makes more sense to factor that out.
Oh, yeah.
Than it does x squared. It's rare that you see a problem like this where you can do both. But let's start by factoring out the 4x minus 3 to the 4th power.
Could you do that in the 5x?
One step at a time. I'm not sure. What do you get when you factor out 4x minus 3 to the 4th power? What is the term that's left here?
So you've got, is it times 5x cubed minus 15x.
Hold on. That's what you get when you divide that by our factor, is 5x cubed. Now, you also get 15x squared times...
Or not minus, plus. Times 4x minus 3.
Right. 4x minus 3 to the 1. So that's the result of the first factor. Now, let's do a second factoring. In other words, let's look at this term here. What can we factor out from that?
Get the 5x squared.
Okay, so here's what we got. 4x minus 3 to the 4th times 5x squared. And you tell me what's left.
Let's see. Don't you just have a 5x? Wait.
Here's what you do. You take your greatest common factor and you divide it into each of these terms. Well, what does that give you?
Into that?
Huh?
Let's see. You just have the 5x.
No. In
You
other
take the
words,
5x.
I am taking this expression right here, and I'm factoring out 5x squared. And what that leaves right here is x. Because remember, this 5x squared times x has to equal this 5x cubed plus 3 times 4x minus 3. Now, make sure you see how I get to this step right here.
To the 4x minus 3.
Where I have the arrow? That's the row I'm at right now.
Yeah.
Okay, and the way I got it was by taking the 4x minus 3 to the fourth, and then I took this expression here and I took another greatest common factor out, 5x squared, right there. And after I factored it out of that expression, I was left with x plus 3 times 4x minus 3. And all of these are multiplied. Okay? So let's now see what we have, because this clearly isn't simplified. So let's do 4x minus 3, all of that to the fourth, times 5x squared times x plus 12x minus 9. You with me?
Yeah.
Okay. Now, might as well distribute that, I think. Yeah, so we end up with 4x minus 3 to the fourth times 5x cubed plus 60x cubed minus 45x squared, all that's in parentheses. And then obviously I can combine the x cubes, so that's 65x cubed, and that's a pretty good answer. In other words, here's my answer. I don't really need to take it further than this. I'm going to write it over here in the upper left. 4x minus 3 to the fourth times 65x cubed minus 45x squared.
Okay.
I think that is your final answer. And the reason you don't want to simplify this anymore is because it involves a ton of math. In other words, taking that to the fourth power, first of all, they don't want you to do that. And if you're not going to do that, then you're left with that times that. All right. Let's scroll down.
I think I did 5 right in pencil.
Okay. Have a look at it. Yep. At least this part is correct. I'm looking at the red is what stands out to me, and now I realize that that's her writing. But this is the first step right there. Not quite sure what you did. You can't really see it all, but it looks like that's what you did. I don't know. But as long as you get that step right there, then the rest of it is algebra 2. In other words, this is a quadratic. And you have to factor it like a quadratic. The way you did it, you come down to there. I don't know, without doing all the math, whether that's correct or not. Looks like it probably is, because No, probably, yeah, maybe it is. Maybe it is. I don't know. It looks like the sign might be off a little bit. It's minus x squared plus 4x plus 4 plus 2x plus 4 plus 3 equals 0. Now let's get rid of that negative sign. So we got x squared plus 4x plus 4 minus 2x instead of plus 7 minus 7 equals 0. Now we got x squared plus 2x minus 3 equals 0. Got that sign right there. Actually, you got it right. Your answer is the same as my answer. What's the problem with your answer?
Is it just the signs are flipped?
Well, it's more than that. This is not easy to factor. Whenever you have a negative sign in front of your x squared term, makes it extremely difficult to factor. So you generally want to give your quadratics with a positive coefficient on x squared. But notice this answer you gave is the same as what I have. It's just I divided everything by -1. And you do need the 0 right there. Equals 0. That's what allows you to divide by -1. The fact that you have an equation and you can divide both sides by -1. And it turns that into that. And then this is factorable pretty easy. That's x plus 3 times x minus 1 equals 0. What are my two solutions?
X equals -3 and x equals +1.
Yeah, you see why it's easier to factor these if I have a positive coefficient? If I have a negative coefficient, then one of these has to be negative, and I'm all confused. I can't apply any of my standard rules. So when your job is to factor a quadratic, do whatever you have to do to get the coefficient of the x squared term to be positive.
Okay.
Number 6. Okay. First of all, if I said to you, what is f of 3? What would you do?
F of 3? Don't you just replace x with 3?
In the f function. Correct.
Mm-hmm.
So instead of f of 3, it says f of r of x. Well, that's r of x. So it really becomes f of 2 over 3x minus 1. Now what do you do?
Wait, you replace all of the, what is it, the x's in the f function with that.
Yes, and that's what she has done right here. In other words, it's 2 times that, which is r of x, minus 1, all over r of x plus 3. Now it's just an algebra problem. Now, do you need me to go through how to solve this algebra problem? I'm happy to.
Could we?
Sure.
A bit rusty.
Yeah. It's, for some reason, this gives people, what really gets people is this integer, the -1 and the +3. But don't let it get you. Okay, so first of all, what I have is 4 over 3x minus 1 minus 1. That's my numerator. Whenever you have problems like this, work with your numerator first and then work with your denominator second. Do everything you need to do with your numerator. Well, what can I do here?
I'm not sure.
How do I do 4 over 3x minus 1 and then minus a 1? What do you do? How do you subtract fractions?
Well, don't you have to get the common denominator?
Exactly. What is it here?
The 3x minus 1.
Okay. So we got 4 over 3x minus 1. What's the second term going to be? We know the denominator's got to be 3x minus 1. What's the numerator got to be?
3x minus 1.
Now, operate on that whole thing. What do you get?
Let's see. What is it? Just 3x.
Hold on. Apply that negative sign to both terms. I really should have put a parentheses around that. You should always put a parentheses around it.
Is that just 3x plus 1 then?
No, that minus gets applied to the 3x. So it's minus 3x.
Oh, yeah.
We got 4 minus a minus 1, which is the same as 4 plus 1, so that's 5. That's my numerator of my numerator. There's the common denominator. Okay? So, we're going to call that our numerator. Now, let's deal with the denominator. This part here. What is my common denominator?
3x minus 1.
That's still 2. What's the right? What's the right numerator?
What is that? 9x minus 3.
I would leave it like this. And there's a good reason for leaving it like that. Is because you can instantly tell that you haven't changed it. That is the number 3. Whereas if you distribute the numerator, now you can't be so sure that you haven't changed it. So just from a point of view of checking your answer, I don't ever distribute these until I have to. Now I have to. So my new numerator is what?
What is it? 9x minus 3?
Plus the 2.
Yeah, plus 2.
So minus 1. And my new denominator is 3x minus 1. So this is my numerator, this is my denominator. Now, how do you divide fractions?
I'm not sure.
You flip the denominator and you multiply. In other words, you turn all division problems into multiplication problems.
Okay.
Was that my numerator? I don't think so. I messed it up. No, I didn't. Yes, I did.
No,
this is right. This is right, and this is right. Okay. So, if I flip and multiply, then I'm going to multiply this numerator by the reciprocal of the denominator. You with me?
Wait. So you...
In other words, here's
okay,
my problem right here. I got to figure out how to divide those two fractions. When you're dividing fractions, it does not matter if variables are involved. Who cares? You flip, you reciprocate the denominator, and you multiply. Instead of dividing, you multiply. You turn it into a multiplication problem. So this is my denominator flipped. That's that right there. And notice what happens. The 3x minus 1 cancels with that 3x minus 1. And I'm left with a very nice answer, which is minus 3x plus 5 all divided by 9x minus 1. There's my final answer.
Okay.
And can I simplify that?
I don't think so.
No. There is no number that I can divide top and bottom by, and there's no variable that I can divide top and bottom by. So that's my answer, unless I've made a math error, which is possible given the way I'm writing this on top of your writing. It's hard to, well, no, it's not your problem. I could do it a different way. Just that if I did it a different way, I would have to copy all these functions. So rather than recopy all those functions, I just did it. All right, so let's go down to number 7. Domains can be a little bit tricky. First of all, the number one rule on domains: you can never violate the domains of each function. In other words, the domain of f of r of x cannot violate the f of x domain, and it cannot violate the r of x domain. So let's start there. What is the domain of each of those?
I'm not sure.
Well, usually when you have a ratio, the only restriction on the domain is that you can't divide by 0, right? So what can x not be equal to in the f of x function?
The 3x, is it just the 3x minus 1?
It can't be equal to minus 3. Notice that if x were equal to minus 3, I'd be dividing by 0. That's the only thing we consider.
On which one, the r or the f?
I've drawn it under the f.
Oh, okay. I was looking at the r.
Now, if we look at the r, what can x not be?
What is it?
And the way you solve it is by setting 3x minus 1 equal to 0. Whatever you get, that's the answer.
It's be just 3x negative or equals 1. So it's 1/3.
Yeah, we have 3x minus 1 equals 0, which makes x equal 1/3. That's the solution as to what x cannot be equal to. Okay? So, based just on the f of x function and the r of x function, we know x can never be these two things. Now, it's also, we need to look at the composite function and see if any other domains pop up. Well, f of r of x means this. We just did it. Did you write down the answer by chance?
It was negative 3x plus 5 all over 9x minus 1.
Notice this has its own domain restriction. In addition to the two original, this gives us what? What else can x not be equal to now?
1/9.
So your domain, let's see, have you had interval notation, Sam?
Probably. I just don't remember this unit very well.
All right. Well, x can be any number you want except one of these three numbers. So if you've had interval notation, then this is the way I would write it. Minus infinity to minus 3 in union with minus 3 to 1/3.
1/9.
No, 1/3. Yes, you're right. 1/9 comes first. In union with 1/9 to 1/3 in union with 1/3 to infinity. In other words, that covers the entire number line except for those three values.
Okay.
-3, -3, 1/9, and 1/3 are the only three things that it can't be. But the important thing to learn from this is that when you have a composite function, you have to look at the domain restrictions of your composite function as well as the domain restrictions of each individual function on its own.
Okay.
Okay? In other words, I said f of x equals square root of x divided by square root of x. Well, that's equal to 1. Doesn't appear to be very many domain restrictions on 1. But that can't be, x cannot be a negative number. And x can't be 0. So the answer to this is 1, with the exception of x cannot, or x has to be greater than 0. So that would be the domain restriction on square root of x divided by square root of x.
Okay.
Always have to go to your original function to find out what really is a domain restriction.
I guess that makes sense.
Kind of like this. I'm sure you've seen this problem. This is a classic problem. Well, if I give you a function like this, immediately you can cross that off and that off. So it appears that the function is equal to x plus 1, but not really. There is a hole. Remember holes? There's a hole at 1. X can never be equal to 1, despite the fact that we crossed it off. It does not eliminate the need for that domain restriction. In other words, originally the problem is that. So x can never be 1, despite the fact that that domain restriction appeared to disappear because there's nothing wrong with x being 1 in x plus 1. But what I'm saying is that always go back to the beginning.
Okay.
All right, let's see. What next? Looks like number 8.
All right, so P, what is it? P of x isn't in the picture. I can just tell you what it is, though.
Okay. Hold on a second. Let me get it so everything is in the picture. Yeah, let me write here. Hold on. What's P of x?
The square root of x squared minus 9.
Like that?
Yep.
Okay. So they want to know the domain of that. So first of all, we have to check the domain of P of x. And then we're going to check the domain of G of x. And then we're going to check the domain of P of G of x. So let's start with P of x. What can x not be? Domain questions are almost always about what x cannot be, not so much what x can be, although ultimately that's what they're asking, but it's usually x cannot be something. In other words, if I take a normal polynomial, x can be anything. It's all real numbers is the domain. But that's not the case here. That quantity right there cannot be negative, right? So let's solve that. has to be greater than or equal to 0.
So can it not be 3 then?
Well, hold on. You're on the right path. Can it be 2?
No.
Can it be 1?
Wait. Does it just have to be? No, it can't, because those would be less.
3. In other words, x has to be greater than or equal to 3, but also x can be less than or equal to minus 3. Those are the restrictions. So if I was doing this in interval notation, I would go negative infinity to minus 3 in union with 3
To infinity.
Yeah, the only range x cannot be is anywhere between minus 3 and plus 3. Because then you'd be taking the square root of a negative number. So there's the domain for P. Now, g of x, is that just x plus 3?
Yeah. So x can't be 3.
No, it can be.
No, negative 3.
What's wrong with that?
With what?
What's wrong with negative 3? This is not a denominator. The only rule in math is you cannot divide by 0. There's no division going on here. This is x plus 3. X can be any number on the number line, all real numbers. In other words, that's the name of the game of finding domain. Can you find an x that is problematic? You said minus 3. Well, that makes g of x 0. There's nothing wrong with g of x being 0. X could be negative 1,000,000. X could be positive 1,000,000,000. In other words, x can be anything.
Okay.
So there's no domain restrictions from g of x. We found some from p of x. Now let's look at p of g of x. Well, that's p of x. Is that x plus 3? I want to make sure I'm reading it correctly.
Yeah, it is.
G of x is x plus 3?
Mm-hmm.
Okay, so p of x plus 3 is what?
Let's see, isn't it the square root of x plus 3 squared minus 9?
Yep.
Aren't the x plus, yeah, that's parentheses. Okay.
In other words, that's all you do. Whatever it's real simple. Whatever is in the parentheses, you substitute for x. And it's generally a good idea to put them in parentheses when you substitute for it. As you can see why. If I didn't use parentheses there, it would have a whole different meaning. Okay. Now, let's simplify that a little bit. That's x squared plus 6x plus 9 minus 9. So the 9's disappear. So there you have p of g of x. Now, what restriction exists there? How do I solve for it?
Don't you set that to
Greater than or equal to 0. Over here on the right, that's how I'm going to solve for it. Okay? Now, that's actually not trivial to solve. Let's see. For that to be positive, x has to be less than 6.
less than 6?
Excuse me. If x were less than 6, that's negative. No, excuse me. Let's go back here. Let me solve this properly.
Shouldn't it just have to be greater than 0?
No, this is a lot harder than it looks. But you need to know how to do this. So let's go through it. got to use a sign chart. And I want to put my critical numbers on the sign chart. What are my two critical numbers?
For the
For this
X,
function right there. Trying to solve.
is it just 6 and 0?
So I write those on the sign chart. It's not 6, it's negative 6. In other words, it's whatever makes these things 0. Those are your critical points. Well, if x is 0, that thing is 0, and if x is negative 6, that thing is 0. Okay? Now, the way you solve a sign chart problem like this is you pick any number you like to the left of minus 6. So pick minus 7. Okay? That makes that negative. That makes that negative. A negative times a negative is a positive. That means all numbers to the left of minus 6 are positive.
So is it just negative infinity to negative 6?
Yeah.
I guess would it be a bracket?
Hold on. We're not done yet. Now we got to pick a number between minus 6 and 0. Let's pick 1. Or, excuse me, negative 1. So that's negative. That's positive. So it's negative in this range here. And then if you pick a number to the right of 0, you'll see that's positive, positive times positive is positive. These are all positive also. So what's my domain?
So can't it be all real numbers except for negative 6 to 0?
Correct. Okay. So now we have to combine that with this domain up here.
Okay.
This domain was all real numbers except between minus 3 and plus 3. So if I just extend that, ooh, no, that doesn't work. I got to go to minus 6. So it's got to look like something like this. I hope you can follow this. There's so many numbers on the thing. Okay, so I can go to minus 6. Can't have any numbers between minus 6 and 0.
So then how do you have the negative 3 from the other one?
I don't. I go from 0 to infinity. Now let's see. Let's see. I can't go. I go from 3 to infinity. So right there is my final answer that combines all the domain restrictions that I need to combine.
Okay.
In other words, I have a domain restriction from P of X. I have a domain restriction from P of G of X. But that's it, those two. And when you're talking restrictions, whatever is the most restrictive. In other words, I couldn't have anything between minus 3 and plus 3, and I couldn't have anything between minus 6 and 0. So I just have to work around it. So that means that I can't have anything between minus 6 and 3.
Okay.
Yeah, it looks like you did all the work correct here. I noticed something here. Curious about. How'd you get from there to there without using a sign chart?
I have one up at the top.
Because you set it equal to 0. You're not supposed to set it equal to 0.
Okay.
It's got to be greater than or equal to 0. In other words, remember that you just merely cannot divide. You cannot take the square root of a negative number. So everything that's inside the radical sign has to be greater than or equal to 0. And you end up getting answers that are pretty good, but not really. That's not really the answer. You haven't specified whether x has to be less than 0 or greater than -6 or less than -6. In other words, this is not correct.
Okay.
And you can't, in fact, solve that problem without doing a sign chart. You need to start from here. And that needs to be greater than or equal to 0.
Okay.
And then you factor it into that step. And then you figure it, then you draw your line chart and you figure out your critical points. That's the only way I know how to do those. Same problem as, let's say you had this problem right here. What are you going to do? You don't know how to do that. I don't either.
Yeah.
But if I draw a line chart, what are my critical points?
Isn't it, was it 2, -1, 0?
No, it's -2. It's whatever makes the numerator 0, and it's whatever makes the denominator 0. So
just -2 and +1.
And +1. And notice that I do not put 0 on my line chart. It does not belong. The only thing I want to know is what happens to the left of -2. Well, if I plug in -3 here, it's positive. What happens between -2 and 1? Well, if I plug in 0, it's negative. Now what happens to the right of 1? It's positive. So that gives you your answer, because we know this whole thing has to be greater than 0. Well, that's the area that's greater than 0, and that's the area that's greater than 0. So your domain on the function that I just put down would be -infinity to -2 in union with 1 to positive infinity. And that's not that obvious from looking at it. I have never figured out a nice, easy way to do it without a line chart. So these line charts are crucial whenever you have an inequality. When you have a quadratic that's either greater than or less than 0, or you have a rational quotient that's either less than or greater than 0, you've got to use these line charts. Okay, that was number 8, correct?
Yeah.
That all we got?
I sent you another email.
Okay.
I think I sent you the same problem twice, though. So just use the top.
Let's have a look at it.
Yeah, just use the one on the left. It's the logs, because I don't remember how to do logs very well.
Okay. Three rules that are an absolute must to know. Hold on a second. Just got to memorize it. Actually, they're the same rules for exponents. Why? Because logs are exponents. So, rule number 1. If I have the log of a times b, that's equal to the log of a plus the log of b.
Isn't division just subtraction?
Yep, that's rule number 2. The log of a divided by b equals, notice you never do the same on the right side as the left side. Always different. If I'm dividing, I'm subtracting. If I'm multiplying, I'm adding. And perhaps the most important rule is this one. The log of a to the b power equals b
log
a. Notice I'm multiplying on the right, and I was exponentiating on the left. So the right side is always 1 mathematical step less than the left side, right? In other words, addition is one less step than multiplication. Subtraction is one less step than division. And multiplication is one level down from exponentiation. So, now the thing is you have to know these rules both ways. You have to know them to the left to right and from right to left, because they're going to ask you an equal amount of problems. So, in other words, this one right here, we have to condense. So, which rule would you use?
Don't use the second one.
Correct. So what do we got? We're going to turn this into a single log. Now, these rules only work if the bases are all the same. And in this case, they are. So what goes in the argument?
Isn't it x squared minus 9 all over x plus 3?
That's all equal to 3.
And it all equals 3.
Now, the numerator factors, that's difference of perfect squares. So it factors into x minus 3 times x plus 3. So this thing now becomes x minus 3. With me?
Yeah, I'm just writing it down.
Okay. Now, how do I solve that? How do I solve, once I get it into a single log equation, how do I solve it?
Can't you make it into the exponential?
Exactly.
Form?
That's always the way you solve it, is you turn it into an exponential equation. And the way you turn a log equation into an exponential equation, I have one very simple way I remember. It's the number on the far left raised to the power of the number on the far right equals the argument in the middle. So what I have is 4 cubed equals x minus 3. Now we have an algebraic equation that is easily solved. 4 cubed is 64 plus 3, 67 equals x. There's your answer.
Okay.
Okay. And when you are solving log equations, there's one extremely important thing to do. And that is to check your answer to make sure you don't violate any domains. There are severe domain restrictions on log functions. You can only take logs of positive numbers. You can't, it's worse than radical sign or square root. You can't even take the log of 0. So sometimes when you solve a log equation, especially one involving quadratics, you will get 2 answers. Almost always one of those answers violates a domain. In other words, let's say we came up with x equals minus 4. Let's just assume that that's the answer we came up with. Well, that doesn't work. That violates that domain right there. X can't be minus 4. Doesn't violate this domain, because minus 4 squared is 16 minus 9, so it's fine here, but it doesn't work there. So that cannot be an answer. If that was the only answer we came up with, then this one would have no solution. But usually it's when you come up with 2 answers, one of them violates the domain. I'm sure they're going to give us one. Let's do it real quick before we run out of time. So tell me how I'm going to rewrite 14. As a single log expression.
Let's see. So you just, let's see, so it's log of, is it just x and then in parentheses x plus 15?
Yeah, let's go ahead and multiply that out. X squared plus 15x, correct? other words, that's the same thing as that.
Equals 2.
Okay, now put that into an exponential expression.
Let's see. See, isn't it just 10 squared equals x squared plus 15x?
Correct. Now we're going to solve that. We get 0 equals x squared plus 15x minus 100. Now we need factors of 100 that subtract to 15. Sounds like 20. X plus 20 and
Yeah,
x
20 and 5.
minus 5, which gives us two solutions. X equals minus 20 and x equals 5. Now, when you check your solutions, very important not to check against that. Always go back to the original. The reason is that neither one of these solutions violates that domain, but one of them does violate that domain right there. You cannot have
The negative 20.
minus 20. In fact, it violates both that domain and that domain. So this solution gets thrown out, and x of 5 works because now we have the log of 5 plus the log of 20. Is that equal to 2? And if you stick that in a calculator, you'll find out that it is.
Okay.
But this is a perfect example where I ended up with a quadratic, so I know I'm getting two answers, and I'm almost 100% sure that one of those answers is going to violate the original domain restriction. What's extremely important here is that you don't test them on your first step. In other words, the first
Test them on the original.
the first step that I did was apply the rules of logs to convert it to this. And that's fine for a first step of solving the problem, but it's not where you want to go to check your domain.
Okay.
Because notice minus 20 doesn't violate that. Minus 20 squared is 400 plus a negative 300. That's positive. So neither answer violates that domain. That's why it's really important to go back to the original domain, because that's almost always the case, is it won't violate your step 1, but it will violate that. And that tells you a little bit mathematically also. These things aren't exactly the same. They're the same for the purposes of us coming up with an answer, but they're not exactly the same. I cannot say that original number 14 is equal to this, because they're not equal. They have different domain restrictions.
Okay, so always check by the original instead of the...
Always, always, always. Never check with this
They
first
could
step.
give you different answers.
You won't get the right answer if you do.
Okay.
Always have to go back to the original. All right. Is that all we got today, Sam?
Yeah, it is.
Okay. Sounds good. I will talk to you next time.
Thank you.
You're welcome.